an activity theory analysis of search and rescue collective sense-making and planning practices. Search and rescue, or SAR, is a disaster response activity performed to locate and save victims. It primarily involves collective sense-making and planning. SAR responders learn to search and navigate the environment, process information about buildings, and collaboratively plan with maps. SAR is a socio-technical system that bridges physical, digital, and geographical spaces. It is unique for HCI spaces in that it is not only currently low-tech, but tech-avoiding due to technology's fragility. In this work, we synthesize data from 5 sources. To gain first-person experience with SAR training, we undertook 2 SAR online training courses, followed by 2 visits to SAR training facilities and headquarters. After that, we conducted in-depth interviews with highly ranked SAR responders to understand planning practices and training methods. To reach additional responders, we sent an online questionnaire to SAR responders. Finally, we identify key documentation from online sources of different SAR teams across the southwest of the United States. These 5 data sources were necessary to provide a deep understanding of SAR work. These data sources complement each other and provided a multifaceted view of SAR, providing more diverse input and triangulating findings. To analyze all of these data were grouped for easy access and coding. As each of the coders engaged the data, we began to identify potential themes around the concepts of information seeking, sense-making, and planning. We examined the themes the data were assigned and created subcategories or new themes as they emerged. One aspect of these categories and themes that emerged was that the data lent itself to activity theory as a theoretical lens. The activity theory analysis revealed rich culture and contextual factors that influence our work and training. It helped us to understand and characterize the interactions, tensions, and contradictions within the complex socio-technical environment of SAR, which will drive future system design. Our findings suggest that information seeking and reconnaissance are a central part of SAR training. There are differences within SAR communities on how to mediate these activities. The type of information needed in the operational zones differ, requiring different ways to handle and visualize such information. Our findings critically point to the importance of geospatial information during the SAR planning process. The creation and manipulation of maps is central. Remote interaction and collaboration will always pose problems, which suggests that new and innovative solutions are needed, especially as new tools, technologies, and sources of information are adopted by SAR communities. Based on our findings, we developed design applications for systems that will support SAR in the field or enable training systems to simulate essential components of work practice. Our analysis showed that disaster responders use physical and digital artifacts interchangeably, as each mode offers its own affordances and constraints. We observed that individual and collective mapping is central in SAR work. Responders collect information from reconnaissance missions, use maps to navigate and keep track of plans, and share the information they collected individually with the rest of the team. Plans rely on the right inputs from diverse sources at the right time. Differences in information richness, needs, and representations within SAR communities and the operational zones need to be taken into consideration. Practice involves a constant transition among different roles and activities, with shifts in units of command. By bringing SAR to HCI, we provide a rich area for research and design focusing on practical deployment that concurrently increases the resilience of information communication technology. The present research extends prior work in disaster response practice and training and encourages future research in this area. Thank you.